We're going to be graphing polynomials using a graphing calculator and identifying zeros, relative maxima, and relative minima. So after we use the graphing calculator to graph, we're going to identify the maximum number of turns the graph could make, the number of real zeros, we're going to approximate each zero to the nearest tenth and approximate the relative maxima and minima to the nearest tenth. Okay, so I'm going to start out and I'm going to use my graphing calculator. So I'm going to use the y equals button and I'm going to type in this function. So we have x squared. On my calculator I just type in x and then I hit that squared button and it gives me x squared plus 2x minus 3. And then I'm going to hit graph. Okay, I can kind of see what the graph looks like, but I can't tell exact points. It's kind of difficult. So most graphing calculators have this table listed here. That's my second function of graph. So I'm going to hit second table. And now I can really identify what the values of the points are. So I'm just going to use this to graph it. So this tells me when x is negative 5, y is 12. That's off my graph. When x is negative 4, y is 5. When x is negative 3, y is 0. When x is negative 2, y is negative 3. When x is negative 1, y is negative 4. When x is 0, y is negative 3. When x is 1, y is 0. Let's keep going down, see if there's others. One more. When x is 2, y is 5. So when I graph this, this is what it looks like. Whoops, it is a parabola. It's going to continue going up both sides. All right, so the turns. Well, the maximum number of turns is always taking the largest degree and subtracting 1. So 2 minus 1 is 1. And yes, there's only one turn. Okay, real zeros. Those are the points where your graph goes through the x-axis. So here are my points. And I can also tell, looking at my table, whenever y is equal to 0, remember on the x-axis y is equal to 0, those are my coordinate pairs. So I just want to look at, there are 2 of them. So I have 2 real zeros. And their values are where x is negative 3 and where x is 1. Values of the 0 is where x equals negative 3 and x equals 1. Okay, so now I need to look at relative maxima and relative minima. Well, I don't have a relative maxima because I don't have any curves up, but I do have a relative minima down here. So I'm just going to put just a line through it. So I know there's no relative maxima. The relative minima, you can kind of guess the coordinates, but I want you to try to approximate to the nearest tenth. So one thing that you can do, most calculators have this calc or calculate button when you're dealing with your graph. So I'm going to hit that and I can scroll through these and I can actually find the minima value. So I'm going to hit enter and it says left bound. That just means get on the left side of that minima. So I'm just going to arrow over. Here I'm hitting the arrow over here till my little cursor gets anywhere on the left side of that minima. I'm going to hit enter. Then I'm going to, it's asking for the right bound, so I'm going to go to the right side of that curve, anywhere on the right side. I know I'm past the curve to the right. I'm going to hit enter. It's giving a guess. Okay, and it tells me the minima is where x is negative 1.00001. Might be another 0.000001. Y is equal to negative 4. So if you round to the nearest tenth, the coordinates are negative 1, comma, negative 4. All right. So that one wasn't too bad. Let's try another one. So this one, we have negative x to the 4th plus x cubed plus 4x squared. So here, I'm going to hit y equals, I'm going to clear this. I have negative. Remember, hit the negative button, not the minus. Okay, so we have negative x to the power of 4 plus x to the power of 3 plus 4x squared. Double check that I typed it in right. I'm going to graph it. All right, so I do see I have a few different turns. I want to know exactly what this looks like before I start graphing it. Okay, so now I'm going to hit the table button. Okay, so this first point, well, negative 72 is way off my graph, so I know that's not going to work. But the second point, I can kind of tell where my graph's going to start at, where it's going to go onto my coordinate grid at. So I'm just going to kind of approximate this. When x is negative 2, y would be negative 8, which is off my graph, but I'm just going to put a dot there so I know that that's where my graph's coming up from. So when x is negative 1, y is 2. I'm just going to start my graph. I know that was one of my turns. Let's see, when x is 0, y is 0, so it turns down here. When x is 1, y is 4, we have to go back up. Let's see, when x is 2, y is 8, so I am going to draw that off my graph. It's approximately up there, but when x is 3, y is negative 18. That means that it flips down and goes way down off my graph. So I do need to know that it turns again. That's why you wanted to look at that picture of your graph before you did anything. Because if I had thought, oh, I'm off my graph, I'm done, well, technically you're not. It has to come back down. All right, the number of turns, well, I can look at it and see there are 1, 2, 3 turns. But the maximum number of turns is always the largest degree minus 1. 4 minus 1 is 3. And so our graph does have the maximum number of turns. There are 3. All right, our real zeros. We have 3 of them, where they go through the x-axis. So I'm going to look back at that table and see if I can see where y equals 0. All right, I have one of them, but these 2 points aren't quite as specific. So remember that button, mine's a calculate button. So I'm going to hit second, and I can identify some zeros here. I want to identify that first 0. So left bound is just getting to the left of that 0, well, or below. So now the right side. Okay, so it's where I'm going to go to the nearest tenth. So x equals negative 1.6 is my approximate value. Okay. This value in the middle, I know when I looked at my table, it was when x is 0, y is 0. So I do know that this value right here is where x is truly equal to 0. Because if it's a point on your table and it does show where y equals 0, that x value is your true x value. All right, so then I have one more point I need to look at. So I'm going to go back to calc and enter 0. Okay, left bound. So I need to look at this 0 over here. So I'm going to scroll way over until I'm just to the, whoops, I'm going to go back left of my 0. And now to the right. And the x value is 2.561. And it continues, so 2.6. 2.6. All right, so I have 2 relative maxima, 1 relative minima. All right, so let's look at, we go second calc. Well, let's look at that relative maxima. Let's start with this one. Okay, so I'm going to go to the left side of, I'm starting over here, so I have to get to the left of that curve. Press enter. Now the right bound to the right side, and I don't really want to guess. So my value is negative 1.1, comma 2.0. All right, so relative maxima, negative 1.1, comma 2. And I do have two relative maximas, so I have to do the other one. So I'm going to hit my maxima again, and I want to get to the left, and now to the right of that maxima, so anywhere to the right. I don't really want to guess. So 1.3, comma 8.3. So I have two coordinate pairs, 1.3, comma 8.3. My other one, negative 1.1, comma 2. All right, my relative minima, that's where it curves down here. This one, we did know that for the minima, if you want to check it, you can always check it, but we did have that coordinate pair where it was 0, 0, but you can always double check yourself if you want to. Oh, it's giving me a minima that cannot be right. So I am just going to use the value from the table. 0, 0 is this point right here. So my relative minima is 0, comma 0. All right, here are two for you to go ahead and try. When you're ready, I will go through the answers with you. All right, so I'm just going to type this into my calculator. X squared minus 2x minus 3. Okay, when I graph it, I know it is U-shaped. So we can look at, hopefully you looked at the table, and you said when x is negative 2, y is 5. When x is negative 1, y is 0. We have 0, negative 3. We have 1, negative 4. 2, negative 3. 3, 0. And 4, comma 5. And hopefully your table looked just like mine. So when you graph it, we have our parabola. All right, maximum number of turns. 2 minus 1 is 1. Real zeros, there are 2 of them. The value of your zeros, hopefully you went to calculate, you had your 0. Left bound, right bound, and it says negative 1, 0. So x is equal to negative 1. So it is truly negative 1. And you could also get some of this information from the table. So there's two different ways. We did see that here's where y is 0. So the x coordinates are negative 1 and 3. So kind of easier to use that. Then your last one is your minima. And you can use the function on your graphing calculator to help you out with that. So practically 1, if we round this, 1 comma negative 4 is the value of our minima. And there was no maxima. All right, last one. Okay, we have x cubed plus x squared minus x minus 3. So I'm going to graph it. This is what it looks like. So then go to the table. All right. We have negative 2 comma negative 5, negative 1 comma negative 2, 0, comma, -3. So it does kind of dip down. Let's see. We have 1, -2. And then we have 2, 7. So off our graph. And I can just go back and double check to make sure this is what it looked like in the graph. Make sure I didn't do anything, miss a curve or anything, and it does look like that. So the maximum number of turns, 3 minus 1 does give me 2. And while there are 2 turns, real zeros, there's one point where it goes through our x-axis. All right, so the value of that 0. Whoops, we have our real 0, so left side, right side, and it is at 1.4, comma 0. So that means it's for x equals 1.4. All right, we do have a relative maxima and a relative minima, and I'm just going to double check using start with my maxima. All right, so maxima is way over here. Okay, so that's the left side, right side. See, -1, comma, -2. So it was that coordinate pair from the table. I just wanted to double check, make sure. And we have our relative minima. We are on the left side of it. I'm just gonna move it over a little. And now we are on the right side. And so it would be 0.3, comma, -3.2. 0.3. -3.2. Hopefully you were able to get all of that information from using your calculator, and you were able to graph each polynomial.